Okay. Now let us start with module 3, that is system interconnection. So what we do is, a system is an interconnections of operations that transforms the input signal into an output signal with properties different from those of input signal. For example, let us say a given a raw music signal, you want to remove the noise, amplify it, and add some background music to the signal and get the final output. So what you are doing, you are taking the original signal, then the first part you are going to remove the noise, and second part you are going to add some music to already existing. Next part you can compress the signal, and then you will get the output signal. This is what is the total system doing. So what I will do is, I will represent the output of any system y of t as t of x of t, where this is for the continuous time systems. Okay, so this I will represent it by x of t is equal to, is the input. A system is defined by the transfer function t of dot. So that will be given to you. That transforms an x of t into y of t. Y of t may be simply the amplified part of the x of t, or simply attenuated part of x of t. That's a simple example. You can always encode the signal, encrypt the signal, compress the signal. You can do many operations. But this is the simple implementation which will show x of t is given to a system which will produce y of t. Same way, I'll write in a discrete time domain as y of n is equal to t of x of n. That is nothing but x of n. T is a transfer function which will modify the signal x of n to produce my y of n. Now let us take a simple example. Consider a discrete time signal y of n is equal to half of x of n plus x of n minus 1. So it is the sum of present signal x of n plus the delayed signal x of n minus 1. X of n is delayed by one sample. Now let us denote s to the power k, which will shift x of n by k sample. That is, for example, if k equal to 1, means it will become s power 1. So what happens? X of n, if you apply s power 1, it will become x of n minus 1. If k is 2, x of n becomes x of n minus 2. If k is minus 1, then x of n becomes x of n plus 1. So k is a parameter which will indicate such that input signal gets shifted by k time units. So that's what I told you. X of n is shifted by k times to produce a signal which is x of n minus k. So t, I'll define it as half of x of n minus 0, that is, signal is not shifted. When signal is not shifted, k will become equal to 0. S power 0 is 1 plus x of n minus 1. How much time you are shifting? You are shifting by 1 time unit. S power 1, that is yes. So t I can represent as half. Half is outside, 1 plus yes. So this is how I'll represent a system. Okay, so given x of n, this system with operating function 1 by 2 into 1 plus s will produce an output half of x of n plus x of n minus 1. Any doubt till now?
Explain once again.
I'll explain. See here. What I'm telling, consider a signal y of n is equal to half of x of n plus x of n minus 1. It is a discrete time system which sums the present input x of n plus delayed x of n, that is by x of n minus 1. Now what I will do, I'll define an operator s power k, which will denote x of n shifting by k time units. For example, assume k is positive. If you assume k to be positive, if you write s power 1, if you apply to x of n, it will become x of n minus 1. If you make k equal to 3, then x of n is applied, it will become x of n minus 3. So if k is minus 1, it will shift the x of n backwards, that is x of n plus 1, x of n plus 3, so on. When I want to design a system, I want to represent the entire thing by a system T. So what I will do, my input to the system is x of n only. Output of the system should give me half of x of n plus x of n minus 1. So what I will do, I'll take 1 by 2 outside, it's a constant. First, what should I get? X of n. So x of n means it is not shifted. So x of n is multiplied by s power 0. That will become 1 plus x of n minus 1. That is x of n is shifted by 1 time unit. That is s power 1. That will become s. So my system T is such that 1 by 2 into 1 plus s, which represents x of n plus x of n minus 1 at the output. So this you have to understand. Is it clear? So this is how I will design certain systems. Any doubt here? Any doubt?
No, sir.
Now, how do you represent these systems is the issue. There are two ways to represent the system. Let us write one simple system. This system only I will represent. So it is 1 by 2. T is equal to 1 by 2 plus 1 by 2. Yes. What I will do is first I will implement 1 plus yes. How do I implement 1 plus yes? X of n. It is given as it is. Look here. X of n, that goes to the output as it is, plus x of n is delayed by 1 time unit, that is represented by s. So x of n, when gets transformed by s, it will become x of n minus 1. So I will add x of n minus 1 to the output. So what is the final output here? X of n plus x of n minus 1. Finally, what I will do, I'll multiply this signal by a scaling factor 1 by 2, which will represent y of n. If you represent the system in this format, then it is called as cascade representation. Okay, so you have x of n, also x of n goes through s to get x of n minus 1 to get y of n. That is formed as cascade representation. There is one more representation available, that is known as parallel representation. So what you will do, x of n that goes to output, then x of n, same x of n is sent to s, and that will become x of n minus 1. So there are two different paths. So x of n one directly, and x of n, same x of n is sent to via s, that will give me x of n minus 1. Once you get both of them in the summer, you are adding, that will get multiplied by 1 by 2. That's a scaling factor, that is y of n. This is known as parallel realization. Okay, see here input is 1 here, that goes divides into two sections. Same principle here also, input goes directly here one path, and input goes to yes on the another path. So this is known as cascade realization, and this is known as parallel realization. Is it clear to you? Any doubt in the realizations? Any doubt? Are you able to follow?
Yes, sir.
Okay. Now what I will do, I'll take one more example. An output of a discrete time system is related to input x of n as it is. See here, y of n is equal to a naught x of n plus a1 x of n minus 1 plus a2 x2 of n minus 2 plus a3 x of n minus 3. This is your input output relation. Now I have to design a system in a cascade representation, and another one is a parallel representation. So what you do is first write the system. Y of n equal to this much. So you know that when you apply s power k to x of n minus n, x of n, it shifts the input x of n by k time units. That is, s power k transforms x of n into x of n minus k. When you do this one, so let us apply this one. A naught into x of n. Okay. Now a1 I'll write as it is. So when I make k equal to 1, it will become x of n minus 1. Therefore, I will write s power 1 into x of n. Similarly, this will become a2 into s power 2. That is, input is shifted by 2 time units. That's why I'm writing s power 2 into x of n. Similarly, this will become a3, and this will become s power 3 x of n. Is it clear to you? I simply use this equation. Wherever x of n minus k is there, replace it by s power k into x of n. That's what I'm doing. If k becomes 1, I'll replace it by x of n minus 1. If it is 2, then I'll replace s power 2 into x of n. That's what I'm doing. Once I do this one, I'll take a common throughout this one. So I got A naught plus A3s plus A2s square plus A3s2, and this entire thing I am going to call as T of x of n. This is a system. If given x of n, it will produce the output y of n. What is your T? T is nothing but A naught plus A1s plus A2s square plus A3s cube. Are you able to follow? Any doubt?
Yes, sir. No, sir.
Any doubt? Once you don't have any doubt, now we will implement in two methods. I'm showing you two methods parallelly. Here, I have to implement this equation. So what happens? X of n is your input. So A naught into x of n, A naught into x of n, that goes to the output, plus A1 into S. Here, S is here. That will obtain x of n minus 1. You go to the basic equation only if you want. A1 into x of n minus 1. So x of n minus 1 is produced by S multiplied by A1. Similarly, I'll produce x of n minus 2 and multiply by A2. Look here, A2 into x of n minus 2. This one, A2 into x of n minus 2. Once again, I'll go to S, produce x of n minus 3 and multiply by A3. That will give me this one. Okay, this gives me y of n. Okay, so I'm writing this basic equation. I'm not doing anything. I'm simply writing this equation. That's all. A naught into x of n plus A1 into x of n minus 1 plus x of n minus 2, x of n minus 3, I'm obtaining. That gives me the final answer. See here, this is your cascade implementation. So one delay that will be added to this delay will get added in this next section, and this delay will get added in this section. That's why it is called as cascade. Look here how parallel implementation you are going to get. Same x of n is given here, multiplied by a naught. A naught you are going to get at the output. Next, a1 into x of n minus 1 half. So that will be multiplied by s power 1. So this is the second part. Now I should implement x of n minus 2. But what is available to me is only x of n. Therefore, I will delay it by 2 time units. That will give me x of n minus 2. I'll multiply by a2 to get me the final answer. Similarly, x of n, I'm going to delay it by 3 time units. That will give me this one. Hence, multiplying by a3, I'm going to get the answer. So, when compared with the serial implementation, parallel implementation needs 3 plus 2, 5, 6 delays it needs, but here you need only 3 delays. Therefore, cascade implementation is advantageous because it needs less number of delay elements. But parallel system is advantageous, it is faster because all the three paths are independent of each other. But here, each path, output of this one depends on this one, and output of this one is dependent on the previous one. Okay, that is the advantage and disadvantage of both the methods. Any doubt? Are you able to follow?
Yes, sir.
Okay. Once you know this one, I'll pick up some more problems. Consider the interconnection of LTI systems. Okay, x of n I have h1 of n plus h2 of n, h4 of n, h3 of n. These are systems is interconnected like this. I want to know what is the total h of n of the system. So if they are connected in this fashion. So this part of the signal systems is very similar to control systems. Remember, 2 points you remember very carefully. If two impulse responses are connected in parallel, see here h1 of n and h2 of n, output is sum of those two. But only one thing is plus must be written. If one is plus and another one is minus, then it becomes difference. Okay. So if for parallel connections, you have to add the impulse responses. But for series connections, let us say you have H4 and H5, then it will become convolution of the impulse responses. And remember, not the multiplication. Okay. So parallel correction represents addition, series correction represents the convolution. Okay. These 2 points must be known before you are going to evaluate these functions. Let us see how you are going to evaluate this one. Let us write only this part. H1 of n and H2 of n are parallel. Your output will become H1 of n plus H2 of n. What is your H1 of n? H1 of n is u of n and H2 of n is u of n plus 2. So H12 of n is equal to u of n plus u of n plus 2. So I have x of n, and this one I will replace by H12 of n into H3 of n. Here I have H4 of n summation. Are you able to follow? Any doubt? Yeah. Any doubt?
As we discussed yesterday,
Sakshi? Are you able to follow?
No, sir.
See here.
Yes, sir.
Understand, parallel connections are replaced by addition. Series connections are replaced by convolution. Only 2 points remember. H1 and H2 are parallel, therefore are replaced by addition. But what is H1? U of n, and what is H2? U of n plus 2. So I'm taking these. Once I take these two, I'll replace H1, H2 with H12 of n and H3 of n, and this is H4 of n. This one. Is it clear? Once I do this one, these two blocks, H12 and H3, can be replaced by the convolution. H123 of, I'll write it as H12 convolved with H3 of n. That is equal to, what is your H12 of n? U of n plus U of n plus 2. See here, this is U of n plus U of n plus 2 convolved with H3 of n. Are you able to follow? H12 of n is equal to H1 of n plus H2 of n. That is U of n plus U of n plus 2. That is convolved with H3 of n. So I'm writing like this. So finally, what I got from these two blocks, x of n, H123 of n, this is H4 of n, this is plus and minus. Once again, these two blocks are parallel. Therefore, final output will become this H123 of n minus H4 of n. Some radio is playing. What is this noise? H123 of n minus H4 of n. H123 of n is equal to U of n plus U of n plus 2 into, see here, H3 of n. What is, sorry, convert with H3 of n. What is your H3 of n? Delta of n minus 2. So I'll write delta of n minus 2 minus, what is this pattern? H4 of n. H4 of n is equal to alpha power n U of n. Okay. So alpha power n U of n. So this much I have written. Any doubt in this section? Have you got this final answer? Are you able to follow this equation?
Yes, sir.
Okay. Once you are done, remember this one. A plus B convolved with C. That's what you have. So what happens when you convolve U of n with delta of n minus 2? It is simply U of n minus 2. So remember, x of n convolved with delta of n minus k, it will become x of n minus k. That's all. So U of n convolved with delta of n minus 2 is equal to U of n minus 2 plus U of n plus 2 convolved with delta of n minus 2 gives me U of n plus 2 minus 2. So plus 2 minus 2 gets cancelled. I'll get only U of n. Finally, these two terms are over. Finally, I'll write minus alpha power n U of n. So I'll take one U of n common between these two terms. I'll write 1 minus alpha power n U of n. That's U of n minus 2. This solves the problem. Okay, so I'll write the final equation as x of n, h1234 of n, y of n. Any doubt here? Yeah, tell me, any doubt you have?
No, sir.
Okay, so this is a simple procedure of evaluation of convolutions. Okay, so let us get to the next problem. This, once again, h1 of n you have, h2 of n, h3 of n, and I want h of n. Now, once again, what I will do, First H2 of H3 are parallel. Therefore, I'll write H23 of n is equal to H2 of n minus H3 of n. What is H2 of n? H2 of n is equal to delta of n minus H3 of n is equal to delta of n minus 1. So that is delta of n minus delta of n minus 1 I got from H23 of n. Once I go to this one, next step, H1 and H23 are in series. Therefore, what I will do, H123 of n is equal to H1 of n convolved with H23 of n. That is first function H1 of n convolved with H23 of n. This is nothing but, what is your H1 of n? H1 of n is equal to alpha power n u of n. So I written alpha power n u of n, okay, into H2 of n minus H3 of n is equal to delta of n minus delta of n minus 1. Okay, H1 of n is, sorry, alpha power n u of n plus 2 I have. So I'll write H1 of alpha power n u of n plus 2 convolved with delta of n minus delta of n minus 1. Any doubt here? So it is not printed
No,
completely.
sir.
To take alpha power n u of n plus 2 it is. Okay, so that I have written here. Alpha power n u of n plus 2. Now once again the principle remains same. This convolved with this one results in u of n plus 2 only. So how alpha power n u of n plus 2 minus alpha power n remains unchanged, u of n plus 2 minus 1, that is n plus 1. So minus alpha power n u of n plus 1. This is your final equation H1 to 3 of n. Throughout this section, I am going to find the what is final H of n. That is impulse response of the function. Okay. Now, let us go to this one. Next one. X of n is the input. I have H1 of n, H2 of n, H3 of n, H4 of n, Y of n. Can you tell me what is these two? What is the final H of n? Can you guess me?
With H1 of n into H2 of n.
Convolved. Huh. H1 of n. Huh. H1 of n convolved with H2 of n. Next. Kokila, tell.
A power n into
So let us get the result
u
finally.
of n minus 1.
See here, H1 of n convolved with H2 of n plus H3 of n convolved with H4 of n. That will give me final H of n. Okay. So once H of n, H1 of n, H2 of n, H3 of n, and H4 of n are given, finally we are going to evaluate. That's all. So first what I will do, I'll find H12 of n. What is H12 of n? H1 of n convolved with H2 of n. So what is your H1 of n? A power n u of n convolved with delta of n minus 1. So what happens? A power n u of n minus 1. Similarly, H34 of n is nothing but H3 of n convolved with H4 of n. This gives me what is your H3 of n? Delta of n minus 2. Delta of n minus 2 convolved with what is your H4 of n? A power n u of n. That gives me a power n into u of n minus 2. So I got H12 one answer, H34 one answer. So finally what I am doing? I am adding them. So let us add them. H of n is equal to H12 of n plus H34 of n. That is equal to a power n u of n minus 1 plus a power n u of n minus 2. This solves your problem. Any doubt here?
No, sir.
Okay. Now, let us look into this one. Okay. A system consists of several subsystems. They have H1, H2, H3, and H4. What is the final output Y of t? He is asking. So each one of them are defined. What is Y1, what is Y2, what is Y3, Y4, all of them are defined. So what I will do, let us split it like this. X is given, X1, X2, X3, X4. So X1 is the input to H1, X2 is the input to H2, X3 is the input to H3, and X4 is the input to H4. Okay, and one thing you remember, on X1 is equal to X2 is equal to X3 is equal to X of t. See here, this one this one and this one, all of them come from the same input, that is x of t. Hence, I written x of t is equal to x1 of t is equal to x2 of t is equal to x3 of t. Now, what is your y of t? Let us write y of t is equal to this one, y1 of t and y2 of t in parallel. Therefore, they can be added. This sum goes here. So I got y1 of t plus y2 of t. Now it is minus. So written minus. What is the output of this one? y4 of t. So I'm writing y4 of t. So final output y of t is equal to y1 of t plus y2 of t minus y4 of t. This gives me y of t. Now, what is your y of t? What is so that depends on these three factors. Let us get what is y1 of t. Y1 of t is x1 of t into x2 of t minus 1. So that I written x1 of t into x2 of t minus 1 plus what is your y2 of t? Y2 of t is mod of x2 of t. So therefore I written mod of plus x2 of t minus y4 of t is nothing but, see here, cos of x4 of t. Therefore I written minus cos of x4 of t. So whatever is given in the problem, I simply substituted x1 of t, x2 of t minus 1 plus mod of x2 of t minus cos of x4 of t. Now, what is your y3 of t? Y3 of t is input arrived from h3 of t. What is your h3 or y3 of t? Is equal to 1 plus 2 x3 of t. So I'll write 1 plus 2 instead of x3. X3 of t is nothing but x of t. I'll write 1 plus 2 x of t. This is y3 of t is nothing but input to h4, that is x fourth of t. Therefore I written x fourth of t is equal to y3 of t is equal to 1 plus 2 x of t. So I will substitute x4 of t, value of x4 of t in this equation. So y4 of t is nothing but cos of x fourth of t. So this is equal to cos of 1 plus 2 x of t. So I got y4 of t. So y1 of t, y2 of t, and y4 of t, and I can simply substitute the answer. So this gives me x of t and all x1, x2 I made x of t, x of t, x of t minus 1 plus x of t, x2 of t is nothing but x of t minus cos of 1 plus 2 x of t. This is your final answer. Any doubt in the problem? Any doubt?
Sir, repeat the final expression.
See here, y of t is equal to x1 of t into x2 of t minus 1 I written. But x1 of t, x2 of t is same as x of t. Therefore, I written x of t into x of t minus 1 plus mod of x of t, okay, minus. Now, what is your y4 of t? Y4 of t is nothing but cos of 1 plus 2 x of t. This factor I substituted here. How I got y4 of t, x4 of t? X4 of t is nothing but that is obtained as y3 of t. X4 of t is same as y3 of t. How do you get y3 of t? Y3 of t is equal to 1 plus 2 x3 of t. So what is your x3 of t? X of t. Therefore, I'll write y3 as 1 plus 2 x of t. So I written it as x4 of t. This I have substituted in cos. Cos of x4 of t is same as cos of 1 plus 2 x of t. That I have written here. Okay, replace x1 of t and x2 of t by x of t. Look at the input. X of t is feeding x3 of t, it is feeding x2 of t, and it is feeding x1 of t. All these three factors can be replaced by x of t. Hence, I got x of t here, x of t, and x of t minus 1, x of t I got because of this function. Any doubt?
No, sir.
Okay. Now, so okay, now I'll give a simple function x of n. You already know when you put by s, it will become x of n minus 1. Suppose you want to implement this one, 1 plus s square. So what I will do, 1 by 3 I'll multiply. Pre-multiplication are not shown here. Okay, this I've forgotten. You write 1 by 3 and this will become 1 direct path, and this one yes, this path plus s square. This will give me the final output. So what is your actually x of n plus x of n minus 1 plus x of n minus 2 whole divided by 3 will be implemented by this function. Suppose that they give this diagram, you should be able to write the function, that is x of n plus x of n minus 1 plus x of n minus 2 whole divided by 1 by 3. 1 by 3 are not shown here, you have to write here. Okay, so this is how, if this part of the diagram is given, you can write the equation, or if the y of n is given, you should be able to implement in this manner. Is it clear to you? Or any doubt you have?
Yes, sir.
Okay, so if this is given, you should be able to write this one. If this is given, you should be able to write this one. Now, I'll go to system properties in terms of impulse response. All the system properties you know already, but for the impulse response h of n, I'm telling those properties once again. Now you know that memoryless system. What is the meaning of memoryless system? A system is said to be memoryless if the output of the system depends only on the present input. Output depends only on the present input. So let us take convolution. Convolution y of n is equal to x of n convolved with h of n, or h of n convolved with x of n. So what I will write, summation for all values of k, h of k into x of n minus k. So let us expand it. So it will become from minus infinity, I'll take only from minus 1. So h of minus 1 into x of n plus 1 plus h of 0, when you put k equal to 0 into x of n, when you put k equal to 1, it will become h of 1 into x of n minus 1 plus h of 2 into x of n minus 2, so on and so forth on right side and also on the left hand side, because it is an infinite sum. Now, if you say that system is to be memoryless, y of s must depend only on the input and cannot depend on x of n minus k for k is more than or equal to 0. Means y of n should depend only on x of n. It should not depend on x of n minus 1, x of n minus 2, x of n minus 3, or x of n plus 1, or x of n plus 2, x of n plus 3. So all these factors must become 0. And all these factors below 0 also should become 0. So what should happen? H of k, h of 0 and x of n only should exist. Instead of that, what I will write? H of k is equal to c into c is some constant delta of k. Why I chosen delta of k? Delta of k is equal to 1 when k equal to 0. For any other values, delta of k will give you 0. Therefore, this function will vanish. So the system is said to be memoryless system only when h of k obeys the law, h of k is equal to c into delta of k. For CT systems, k is replaced by tau, that's all. H of tau is equal to 0 when tau is not equal to 0. That is nothing but c into delta of tau. So system does not have memory, means there are no other terms which of x of n plus 1 or n plus 2, n plus 3, so on, or x of n minus 1, n minus 2, n minus 3, so on. So it neither remembers the past nor remembers the future. So it depends only on the present, means only h of 0 and x of n is present, the rest all functions are absent. This will happen only when h of k, your impulse response is only c into delta of k. Is it clear to you? Or any doubt you have?
No, sir.
Okay, do one thing, I'll stop here. Okay, subsequent properties I'll go in the next class. If you have any doubt, you just mail me. Okay.